You are made of approximately 37 trillion cells, and they're dividing billions and billions of times every single day, so you can grow, repair and replenish yourselves. If they don't do this, you die. If they do it wrong, cancer happens. So we really want to understand this process because we really want to understand how and why things like cancer happen. Now, cell division is a long and complicated process, so as research scientists we like to focus in on one little bit and just figure out how that bit works. And the bit that I'm interested in is the bit where the cell is trying to decide where to cut. So let me set the scene for you. The cell has already duplicated its DNA. It's separated those identical copies into opposite halves of itself. Now all it needs to do is divide down the middle to give you your two daughter cells, each with their own copy of the DNA. This is obvious to us. We have eyes and a brain, but the cell does not have eyes and a brain, so how does the cell know to cut down the middle? Well, the answer to that question is it gets guidance from these incredible structures called microtubules. Now, microtubules are these stiff cellular fibres, about a thousandth the width of a human hair, and they're dynamic, so they're constantly growing and shrinking and exploring their environment. And these microtubule fibres grow out from opposite halves of the cell until they begin to overlap in the middle, at which point they stop growing, and special protein molecules which recognise this overlap shape bind to it and essentially sew all of the overlaps together, so you're left with a narrow band of overlap down the middle of the cell. And it's this narrow band of overlap that's got out like our cut here line for the cell, because it's also going to recruit proteins important for pinching in the cell membrane and doing the final snip. But frankly, I don't care about the pinching and the snipping. I only care about this structure. How do the microtubules know to stop growing? How do all the overlaps align neatly down the middle? This is a regulated structure, and it's regulated by protein molecules. But these protein molecules are all jumbled up with the protein molecules involved in the pinching and the snipping that we don't care about. So this is just too complicated to figure out how these bits of floating matter obeying the basic laws of physics self-assemble into something that looks so structured. But we can simplify it. Because these are just bits of floating matter obeying the basic laws of physics, which apply as much in the cell as they do out of the cell, we can actually grow these microtubule fibres outside of the cell just in salty water, and I can add the proteins which I think are important for building one of these structures and try and build one of these structures outside of the cell from scratch. Because the physicist Richard Feynman once said, "What I cannot create, I do not understand." That is my thesis. Thank you very much.